Hello everybody. Today we are going to read about a simple rules, okay, which will be called Fleming's hand rule. These rules are often used in electric generator and motors. So before studying electric generator and motor, you have to know about these rules. Okay. Okay. What are the Fleming's hand rule? Fleming's there are two Fleming's hand rule, that is Fleming's right hand rule and Fleming's left hand rule. What are those, and what are the applications of those, and what are those rule states? We'll read forward. Okay. Fleming's left hand rule and right hand rule are essential rules applicable in magnetism and electromagnetism. John Ambrose Fleming, the full name of Fleming is John Ambrose Fleming, developed them in the late 19th century as a simple way of working out in the direction of electric current in an electric generator or the direction of motion in an electric motor. As I have told you, these rules are applicable in electric generator and in electric motor. In the simple way to state Fleming's right hand and Fleming's left hand rule applicable. In Fleming's right hand rule, it is applicable in electrical generator and the left hand in electrical motor. Forward we will read how. It is important to note that these rules do not determine the magnitude. These rules, a simple thing, these rules do not determine the magnitude of electrical current induced or the amount of force induced or the thrust induced in motors. Instead, shows only the direction of the three parameters. These rules only show the directions. Which direction? The magnetic field direction, the current direction, and the force. Force or the thrust induced direction. When the direction of the two parameters known, means there are three parameters, that magnetic field, current, and force. So if the two parameters known, then we can guess the third parameter. That is what these rules state. Okay. So what is, we'll first study what is Fleming right hand rule. Okay. What is Fleming's right hand rule? According to Faraday's law of electromagnetic induction, when a current moves through a magnetic field, an electric current is induced in it. Got it? So, according to what Faraday's law state, Faraday's law of electromagnetic induction state that if any conductor will move through a magnetic field, a current, a electric current will generate in it. Okay. To explain that Faraday's law, just see in this diagram. This is two permanent magnet. Okay, this is north pole and this is south pole. What Faraday's law state, that if a conductor, this is a conductor, this is a simple diagram of electrical generator. So when you study electrical generator, you got to know details about what are those things. But simple to understand the Faraday's law, I will let you know here. When what Faraday's law state, when a conductor moves through a magnetic field, a current will induce in it. These are two permanent magnets, so a magnetic field is induced in it. So the direction of the magnetic field from north to south. This is the direction of magnetic field. Okay. This is a conductor. This is a conductor. This is a conductor. This is move in a magnetic field. The motion will be on this direction as it stated. So from the Faraday's law, it will know that if this conductor moves in this magnetic field, so a current will be induced in this conductor. Okay. Because a conductor moves in this magnetic field, so a current is induced, but the direction of the current will be unknown to us. So here the Fleming's right hand rule comes into the play. The Fleming's right hand rule, what it will state? It will state us the direction of induced current in this conductor. Okay, so we got to know what is Faraday's law of electromagnetic induction from this. So Fleming's right hand rule is used to determine the direction of induced current. As I have said, Fleming's right hand rule here used to determine only the direction of the induced current, not the magnitude, not the amount of current induced. It will not determine, it will only determine the direction of induced current. Okay. So we will now study what is Fleming's right hand rule. Fleming's right hand rule states that if we arrange, listen carefully, Fleming's right hand rule was stated is that if we arrange our thumb, forefinger and middle finger, see into this diagram, this is thumb, forefinger and middle finger in perpendicular to each other of the right hand, perpendicular to each other. In our right hand, if we arrange our thumb, forefinger and middle finger perpendicular to each other as shown in this diagram, then the thumb points the direction of the motion of the conductor. Thumb, what the thumb points? The direction of motion of the conductor. And what does the forefinger points? Forefinger points to the magnetic field of the magnetic field. And what does the middle finger shows? The middle finger shows the induced current direction, the induced current direction. Okay, so if you apply that Fleming's right hand rule on this diagram, on this particular picture, so in this picture what is it? The field is in this direction, so our forefinger will be on this direction and the motion of this conductor will be on this direction, so our thumb will be on upward direction. So what, where does our middle finger shows? Middle finger shows on this direction, so the current direction will be on this direction. So the current will flow in this conductor from A to B, B to C, C to D and D to this brush too. Okay, so in by using Fleming's right hand rule, we got to know the direction of induced current in this particular setup. Okay, so it is, so we will know now what is Fleming's right hand rule, how it will state. So everything we got to know from this diagram. Okay, it is used for electrical generator. This is a simple mechanism of electrical generator only. In this diagram, this is a simple mechanism of electrical generator. This is when we will study about electrical generator, this permanent magnet will be transferred from electromagnet. So this is the simple diagram of electrical generator. Okay, it is used for electrical generator. The right hand thumb rule, right hand, sorry, Fleming's right hand rule is used in electrical generator, where what is the work of a generator? The generator is used to generate electrical current. So the Fleming's right hand rule used to determine the direction of induced current. Okay, so it is used in electrical generator. The middle finger shows the direction of induced current. Okay, the middle finger, this finger, our shows the direction of induced current. In this, okay, this is the direction of induced current. As these are three are perpendicular to each other, so this is the direction of induced current. Here also, this is the direction of motion. The thumb will be set up in downward direction and the forefinger will be in this direction. So the current, induced current, will be in this direction. So from C to D, the induced current will flow. Okay. The middle finger shows the direction of induced current. So we got to know about the Fleming's right hand rule. It is simple if you do this in practical in your home. If you see by perpendicular, making perpendicular are your three fingers, so you got to know about what is the direction of induced current. If the direction of magnetic field and the direction of motion will be laid perpendicular, then the direction of the current will be in your middle finger. Okay. Now we have studied what is Fleming's right hand rule. Now we'll study Fleming's left hand rule. Fleming's right hand rule is used for generator, where the middle finger shows the direction of induced current. Here in the left hand rule, it is used for electric motors. Okay, here the thumb will show the direction of motion. What will in the generator? What for we use the generator? We use generator for generating electricity. What for we use motors? We use motors because to give a thrust to movement, for movement in what will where the motors are placed. Motors are placed in, let's see, in the fan. The motor is one motor, AC motor is placed. When we are switching on the fan, means we are giving electric current to the motor, and the motor moves. Okay, so we use motor for the movement only, the thrust or motion only. Okay, so in the Fleming's left hand rule shows us the direction of motion. Okay, we'll study now. When a current carrying conductor When a current carrying conductor is placed in an external magnetic field, the conductor experiences a force perpendicular to both the field and the current flow's direction. Got it? Means when a current carrying conductor is placed in a external magnetic, in this diagram, see in this diagram. See in this diagram, when a current carrying conductor, this is a current carrying conductor, when it is placed in a magnetic field, this is the external magnetic field, where the magnetic field from north pole to south pole, and when the current is in this direction flowing, take in this loop, in this loop it is flowing from this direction to this direction, from N to M. Okay, so what does it state? When a current carrying conductor is placed in an external magnetic field, that conductor experiences a force perpendicular to it. Okay, we got it. Means this conductor, NM conductor, will experience a force to it, perpendicular to it. So the direction of this force or this thrust will be determined in Fleming's left hand rule, by using Fleming's left hand rule. Okay, what does Fleming's left hand rule state? Fleming's left hand rule states that if we arrange our thumb, forefinger and middle finger of the left hand perpendicular to each other, as in this diagram, if you arrange this thumb, forefinger and middle finger perpendicular to each other, then the forefinger points in the direction of the magnetic field and the middle finger points in the direction of current, then the thumb points in the direction of motion. This is what Fleming's left hand rule states. Okay, so we'll study that deeply in this diagram. Say for this, for example, N M conductor. This is a conductor carrying current from N to M, as this is the positive domain and this is the negative domain. So the current traveling from the positive side through the TS N to M and then to this negative side. Okay, so what the Fleming's left hand rule state? We have to point our forefinger in the direction of magnetic field, the magnetic field from north to south. So this is the direction of magnetic field, this is the direction of magnetic field. And where our middle finger will show? In the direction of current. So this is the direction of current. So if our forefinger shows in the direction of magnetic field and our middle finger shows in the direction of current, so this is the direction of the thrust or motion. Our thumb shows the direction of thrust. So an M conductor will move 90 degree perpendicularly upward, whereas our thumb shows. Okay. So Fleming's left hand rule states that the if our forefinger shows in the direction of magnetic field, this is our forefinger placed in this direction, and if our middle finger placed in the direction of current and middle finger points at this direction, so our thumb direction will shows indicate the movement or the motion of this conductor. So the motion of this conductor will be on this direction. This is the motion of the conductor will be on this direction. So it is used in electrical motors. Okay, why? In the electrical motors we give current and the motion of the conductor will happen. So to know the direction of motion of conductor, we use Fleming's left hand rule. So it is written here, it is used for electrical motors only. The thumb shows the direction of motion. See, this thumb shows the direction of motion. Okay, we got to know about Fleming's left hand rule and right hand rule and where it is used. Fleming's right hand rule used for electrical generators. Fleming's left hand rule is used for electrical motors. So how we got to know about the direction of induced current in Fleming's right hand rule, and in Fleming's left hand rule we got to know the direction of thrust or motion. Okay, so that's it for today. Do like, share and subscribe. Do comment below if you need any other topic to be covered, and do search Navodayan 2012. Thank you. Have a good day.